Good morning everyone. Welcome back to grade 4 mathematics class. How are you all doing today? So we have been learning about shapes. We know depending upon the number of dimensions used to describe a shape, shapes can be one-dimensional, two-dimensional or three-dimensional. What do you mean by three-dimensional shapes? We know when we describe about shapes using three dimensions such as the length, breadth and height, they are called three-dimensional shapes or solid objects. And solid objects or 3D shapes occupy some space. And a solid shape may have a face, vertex and an edge. What do you mean by a face, vertex and an edge? Face of a 3D solid means the surface of the solid object that you are seeing. Here you can see an example. This is the picture of a cube, which is a solid shape. What do you see around the cube? The surface of it. It is called face of the cube. And a cube has got 6 faces around it. One at the back, then 2 on either sides, then 1 at the top and 1 at the bottom. There are a total of 6 faces for a cube. And you can see where 2 faces meet, line segments are there. So the line segment where 2 faces meet is called an edge. And for a cube, you can see edges like this. There are 12 edges for a cube. And where the edges meet, where 2 or 3 edges meet, you can see sharp corner points. And these sharp corner points are called vertices of the solid shape. When you talk about one corner point, it's called vertex and the plural is vertices. Now let us see a few solid shapes in detail. Here you can see a cube. We have already learned a cube has got 6 faces. Which are the faces? 1, 2, 3, 4, 5 and 6. And for a cube, each of the face is a square. So all the faces of a cube are the same. And how many vertices it has got? It has got 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 corner points or 8 vertices for a cube. And what about the edges? We know where the faces meet, there are line segments like these and these are the edges. And for a cube, there are 12 edges. Which are the 12 edges? 1, 2, 3, 4, then 5, 6, 7, 8, then 9, 10, 11, 12. These are the 12 edges of a cube. Now let's see the next solid shape. Here you can see a cuboid. A cuboid is the shape of a shoebox. How many faces does a cuboid have? Similar to a cuboid also has 6 faces. And how many vertices are there? It is similar to cube itself. There are 8 vertices and 12 edges for a cuboid. In a cube, all the faces are the same. All the faces are equal-sided squares. But in a cuboid, it can be rectangular faces. Now, let's see the next shape. Here you can see a cone. For a cone, there is one flat surface and there is a curved surface. So, there is a flat face and a curved face. And you see this sharp point here, it is called the vertex of the cone. So, for a cone, there are 2 faces, one flat face, one curved face. There is one vertex and there is one round edge where the curved face and the flat face meet. Now, let's see the next shape. We have a cylinder here. You can see the shape here. How many faces are there for a cylinder? There are 2 flat faces, one at the top and one at the bottom. And there is a curved face which meet the flat faces on both sides, at both ends. Now, how many faces are there in total? There are total 3 faces, 2 flat faces and 1 curved face. And what about the vertex? Is there any sharp corner point there for a cylinder? No. So for a cylinder, there is no vertex. And what about the edge? We can say the flat faces meet the curved face at two sides or two ends. So there are two round edges for the cylinder. Let's see the next shape. We have got a sphere here and the sphere has only one curved face. Is there any flat face for it? No, it has got only one curved face. And what about the vertex? Are there any sharp corner points on the sphere? No. So there is no vertex for a sphere. And what about the edge? Do any faces meet? There is only one face. So a sphere has got no edges as well. Now let's learn about net of three-dimensional shapes. What do you mean by net of a 3D shape? Suppose you have a soap car or the car of a toothpaste with you. You might have unfolded it, or you might have cut the box and unfolded it or laid it out flat. And then you'll get a pattern which you can fold back together to get the full 3D shape. Initially, it was a 3D shape, and when you cut it or when you unfold it and lay it out flat, you'll get a 2D shape. This pattern that you get when you unfold a 3D shape and change it into a 2D shape, this pattern is called a net of the 3D shape. So what is a net? A net of a 3D shape is a 2D pattern obtained by unfolding the shape. Let me make that more clear to you. Here you can see a cuboid. If you open it or if you unfold it and keep it flat, you will get a pattern like this. And this pattern is called the net of this cuboid. We can have more than one type of net for the same solid object, depending upon how you unfold it or how you cut it open. And if you are given a net, how would you find out if it forms a solid object? See, there are a couple of steps to determine if a net forms a solid object. You have to make sure that the solid and the net have the same number of faces, and also that the shapes of the faces of the solid match the shapes of the corresponding faces in the net. And then you have to visualize how the net is to be folded to form the solid and make sure that all the sides fit together perfectly. See this example. Here you can see a cuboid. See, this is the net of a cuboid. We have unfolded this cuboid and we have got a pattern here. So this was a 3D shape. The cuboid is a 3D shape. When you unfold it, it becomes a 2D or two-dimensional pattern. And this is the net of this cuboid. And see, it has got the same type of faces as that of the 3D shape. And what about the number of faces? How many faces does a cuboid have? A cuboid has got 6 faces. And how many faces are there in this pattern? There are 1, 2, 3, 4, 5, 6. 6 faces are there for this net. What about the shape of the faces in the net or the pattern and the shape of the faces in the 3D solid? Are they the same? Yes, you can see rectangular faces for the cuboid. You can see the same rectangular faces in the pattern as well. So if you fold this pattern back together, you'll get this solid or 3D solid. This is how you can check if a given net forms a solid. Now we'll see the net of a few 3D shapes. Here you can see the net of a cube. You can see the picture of a cube here. What if we unfold this cube? You'll get a two-dimensional pattern or net of this three-dimensional cube. See how many faces it has got? Both the net and the cube has got the same number of faces. It is 6. There are 6 faces for the cube and there are 6 faces in the net as well. And the shape of the faces are also the same. Let's see the net of the next shape. See, here we have the net of a cuboid. We have already seen that in the previous examples. Now, here you have the cuboid and it has got rectangular faces and also square faces on both sides. So, when you make a net of the cuboid, you'll get a pattern like this. So, this 3D or three-dimensional cuboid is changed to a 2D or two-dimensional net. And if you put back this net together, you'll get the original cuboid shape itself. And see the number of faces? The number of faces are the same in both the cases. Both the cuboid, the 3D solid, and the net of the cuboid has got 6 faces each. Now let's see the next net. Here you have the net of a cone. So we know a cone has got a flat face and one curved face. And what if you cut this cone along the sides? And also what if you separate the flat base from it? You'll get a net like this. When you cut open when you unfold the curved face, you'll get a pattern like this. And if you cut along the edges of the flat face and the curved face, you'll get a pattern like this. So this is the base corresponding to the flat base of the cone, and this is the curved surface corresponding to the curved surface or the curved face of the cone. So this is the net of a cone. Now let's see the next one. Here you have the net of a cylinder. So we know the cylinder has got 2 flat faces and 1 curved face. What if you cut the curved face along the length, and if you separate the flat faces from the curved face, you get a pattern or net like this. See, the top and the base. The top and the base, and the curved face, when it is cut open, when it is unfolded, you will get what shape? The curved face is changed to a rectangle. Hope you are clear with this. Now, as a homework, you have to go through these topics once again, and these are in page number 109 and 110 of your textbook. Then you have to do one exercise. You have to complete the questions 1 to 4. 1, 2, 3 and 4 of exercise 7.4. And then in the next page, page number 112, you can see the heading Maths Lab Activity. Please go through that activity as well and do accordingly. So that's all for today, children. We'll meet in the next class with a new topic. Till then, bye.